Hi, everyone.
Good morning, everybody.
Let's give people a minute or two to join and
Hello everyone, it's Adrian from Keysight. I had some audio issue. I hope you can hear me.
we can hear you clearly.
Okay, very good. Okay, I had some issues before. Okay.
Yeah. So okay. So the I think before we give the stage to Hadrian, I would like to do the commercial again about the UA link. There will be a talk in the AI the where is that? I'll dig it out and send it out again, which is the AI system and the on next week, which is May 14th, and the UA link people will give a talk to introduce the UA link. So I hope everyone, if you have time, will be able to join the call and maybe get some summarizing idea about how UA link work. All right. And I'll include the information into the email again. So you will get more clear link information than I'm just talking here. All right, let's Adrian, you good now?
Yes.
All right.
How much time do I have for this report out?
You got we have 30 minutes, right? And then you can take a whole 30 minutes.
Okay, I don't think I need the whole 30 minutes. Okay, it's just to know. I'll try to make it quick. Yes, so last week I attended OCP EMEA Summit in Dublin, and I thought I could make a quick report out to the group to see what were the topics that were addressed, and maybe some talks that could be of interest to this group. Let me share my screen. I think I share the whole screen, yes. Okay, this is not here. Okay. Okay, I'm trying to find, yes, this one. Okay. Okay, and if you have any question, just, let me know and we can discuss during the presentation. Okay, so unfortunately, okay, let me just move this. The schedule already disappeared from the web page. So if you follow this link here, I will share the presentation. You will land on the OCP EMEA Summit for next year. So I don't have the detailed schedule anymore. But on the high level, there was so it took place in Dublin in Ireland on 2 days. The high level agenda, there was a keynote session, the executive forum, which I strike through because I could not attend it. There was a future technology symposium where I had a paper, and then I also attend optics for AI cluster, and this is probably most of the time I will report about this one, which was co-hosted by IPEC. On the event itself, there was 1,100 participants, and it's plus 70% compared to last year. So it's yeah, significant growth. So it seems that the OCP community in EMEA is getting momentum. Just a quick discussion here on the innovation village. So together with, in parallel with the talk, there is an innovation village, a kind of show floor, and mostly 50% of the show floor was about cooling, liquid cooling, and power distribution. So there were really cool stuff to see, like yeah, new liquid cooling rack solution, even some server with immersion cooling, so where everything is in liquid cooling. Here, just for just to show you this big pipes here, this is a rack design that is able, in principle, to cool down one megawatt of power. So really a very interesting stuff on the cooling side. In general, this event, I will cover this later. This is more, it's about data center, but it's more center than data. There are not many discussion around the computing and networking aspects. There are some, but the big aspect is really about the facility, right? So power, cooling, etc. Nevertheless, on the Innovation Village, there was a TE booth, and I had the opportunity to discuss with some TE representative showing yeah, the next, not the next generation. So some implementation of co-packaged copper. So what you can see here are okay, TE solution for co-packaged copper is called Adrenaline Catapult. They are probably from I'm not promoting TE solution, right? But there are a similar solution for from other vendors. This is what is supposed to come close to the chip. It's a compression connector. So here you see the cable here, and here it would be the socket, FTA socket on the chip side. And on the other side, then you have different kind of connector. You can have a OSFP for classical pluggable. You can have also a backplane connector for backplane, for instance, in different form factor. But this was interesting, and this one they are already they are 224G capable. That's my understanding, at least.
So I
Yeah,
have a interrupting in here.
sure, yeah.
Is that 4 OSFP going into one connector or one tiny connector to one OSFP?
Oh, I don't know. I haven't asked. Okay, so I don't know how many. This is a good point. I think we should. I was just showing the new kind of compression connector for CPC. I don't know if this one is going to a single OSFP connector or if it's connected to two. I don't know the breakout. Yes.
Okay. Yeah.
If
Maybe
we
save
look
some
at
money.
here, maybe we can. It seems that we have. Okay, 1, 2, 3, 4, 5. 8, maybe 8 or 16 differential pairs.
Yeah. So that's
TXRA,
about
probably
probably just one.
it's one
Yeah.
connector. Yes.
Yeah.
Okay, there was a keynote session, and my takeaway first, it's too big, and we know about this, but this is interesting to hear this again. There are two big challenges. The first one is a growing gap between the compute and the interconnect capacity. So we know that the machine learning or AI model size is growing very rapidly. So there was this number, figure 100 by 100 every 2 years. At the same time, we have the compute capacity, which is growing 3 times every 2 years, mostly enabled by the new memory, so HP3E and HBM4. So new kinds of memory that really unleash the compute capacity, and on a parallel wave path, we have the interconnect bandwidth, which is only growing by 1.5 every 2 years, sorry. So no, I'm not sure, maybe 3 years. I need to take my note. But there is a discrepancy, right, in terms of growth between the compute requirements and the interconnect requirements. And this has been observed by all the players. So right now we are still okay, but there is a more and more pressure on the networking side of the data center. And the other big challenge is about the power consumption. So the figure I wrote down is up to date in the AI data center, we are around 3 kilowatt per rack. By end of next year, we will have also rack by 500 kilowatt, and by 2030, we will have rack with 1 megawatt power consumption. There are some new. Yeah. Is there a question? No. Okay. So just background noise. Okay. So this for this there was some project by Google, Facebook, and Google, Meta, and I'm not sure who's maybe Microsoft, to have new power distribution for their rack. So basically removing all the power distribution for the rack to have rack only dedicated for computing, and on the next side or next to this rack, a rack full with power units. So I think this project is called Mon Diablo or something like this. So key takeaway about this keynote session is that there is, of course, a big focus on sustainability and decarbonization. Decarbonization includes working with the green energy, but also being sustainable in terms of water consumption, and so on and so on. In terms of AI cluster scaling, Meta has mentioned they want to scale up to 100,000 of GPU for their upcoming Llama 4. So this is something that already exists, and they plan to scale. So well beyond what the scale up can do, and also the current scale out can do. There was something very interesting talk from Broadcom, but I'm not sure if it's really unbiased, right? So Broadcom argued that Ethernet is the right thing to do for scale out and also scale up, and scale up, but still outside the rack, but not with a switch. So scale up and scale out. Sorry for the typos. And that InfiniBand is basically a niche, right? Because it is not capable of scaling as much as it should for the future. So the Broadcom rep was pretty optimistic that the current limitation of Ethernet protocol for scaling out will be addressed by the Ultra Ethernet consortium. So I cannot really give my opinion on this. What I know is that as of today, RoCE is mandatory, even with RoCE, so RDMA over Ethernet. There is still a difference between InfiniBand and Ethernet in terms of performance, and some of the high performance clusters are still running InfiniBand. But it seems that InfiniBand is really limited in terms of scaling out. Okay, so this was from the keynote session, and it was, okay, sorry again for the typo, is a Future Technology Symposium session. So this was very technical talk, very interesting, but most of the talk was again focusing on cooling and power distribution, so very innovative approach. There was I think one talk about computing, combining UCIe and MRAM. Again, sorry for the typo. It's RAM. So it's a kind competing with SRAM for large language model, when you need a larger capacity and you don't need to have lots of speed or lots of data exchange between the memory. And at Keysight, we presented some results showcasing demonstration of link at 448G for optical links and electrical links. And basically, we compare the performance on PAM4, PAM6, PAM8 on the electrical electrical links and optical links.
I think this would be a very interesting observation, especially for us
Yeah,
in the
yeah. So I
optical
can cover
community.
this in one of the future meeting. Yeah.
Yeah.
Yeah. This is very early work, and I think maybe what would be good, there's been also oh no, I think we already have a report out of the 448 OIF workshop, right? That took place in April. Yes, so there were also lots of a good presentation there, but yeah, we could discuss this.
Yeah.
Wait a minute. Yeah, I think I covered this. Yeah, I covered this. And then there was, okay, finally, I think the one that was probably most interesting for the group is there was this Optic for AI cluster workshop. And it was co-hosted by IPEC. So first of all, I knew IPEC, but I didn't take the time to really look in what it is. So IPEC is standardization body, mostly or originating out of China. Everyone is welcome. I think Intel and others are contributing, but it's really a focus on the Chinese market. There's a lot of Chinese players. They are developing their and having their own project that are currently not covered by IEEE, especially on optics. There are some stuff that are very, very specific, I suppose, for the Chinese hyperscaler. One of them is, for instance, they are already looking into 200G per lane multi-mode interconnect. And so 1.60 SR8, for instance. So this is a project they have, and that is, as far as I know, not covered by IEEE. What I understood, and this is very interesting, is that we haven't discussed this yet, but we know there is a strong push we will discuss, I think, in the next slide, but there is a single momentum for going to CPO, etc., etc. But the Chinese market seems to have a very big need for interconnects. And the reason for this is that they don't have access to the latest US designed chips. And in order to have comparable AI workload capacity, they need to connect much more GPUs and chips together than their US and Western counterparts, because they don't have access to the latest GPUs, for instance. So they are still in the race by basically having much larger scale out design. So that's why interconnect is very critical also for this market. So what do I have in speakers? There was a very interesting intelligence, business intelligence presentation by Light Counting. Eric Bernier from Huawei, he introduced the IPEC and optics for AI and 5G, 6G. And then there was different talk from Fujitsu for interconnect, coherent interconnect, AC Link, Cambridge, Yamaishi, and NVIDIA, really on the topic of interconnect. So my takeaway the market is rapidly evolving toward 200G LPO and CPO. So this was a statement from Light Counting. The Chinese transceiver market seems to be more or less decoupled from the rest of the world, because they have developed their kind of own ecosystem due to the technology export restriction they have from the US. So, and also they have different needs, as I mentioned. And also the LPO solution seems to gain some traction in China as well. Okay, so this is not really relevant. What is relevant was about the next generation 448G. This presentation by Yamaishi was already discussed in the 448 a workshop in April in Santa Clara. So I think it's the same content, but I did not attend this workshop by that time. But they have solution for PAM6 and also PAM4 at 448. He presented different kinds of approach. One of them could support 448G PAM4, but what he said, and I didn't have the opportunity to further discuss with him, he said that it seems that the industry is not ready for PAM4 at 448G on the electrical side. So, and this is something that maybe we can discuss in the group, because I see a challenge there. So if the industry, or basically driven by the connector companies, are pushing PAM6 on the electrical side, on the other side we see a lot of transceiver solution and chip vendors that are demonstrating PAM4 optical. So there is a disconnect between PAM6 electrical and PAM4 optical. For CPO, maybe it's not a problem, but for transceivers and things like this, it means that we will have to work with a gearbox. And usually the gearbox, they are, so to transmit, to convert the PAM6 into a PAM4 and the other way around. And these gearbox, they are usually expensive and power hungry. So I think there is still something, also a topic to discuss for us. Okay, even though we should propose some direction or ideas, but do we think that an ecosystem with PAM4 on one side, on PAM6 on the other side, and with a gearbox in between, is it sustainable or not? And finally, there was a good presentation, also very good presentation from NVIDIA, showing their next generation silicon hybrid modulator. And I have some screenshot about this, so I would like to show you what I have. Okay, now the first one was, okay, this was the NVIDIA. So this is basically what they are doing right now. Their CPO solution. So you have the optical engine and the ASIC on a substrate here, on the same substrate. And what they want to do is bring this on a silicon interposer and do something which is called a 2.5D integration. And they believe it can be more energy efficient and also have more bandwidth density. Here on the left, you see one slide from light counting. Maybe it's hard to see, but it's 800G market, 1.6T and 3.2T market, and the green stuff is CPO, right? And you see the CPO, according to light counting, being dominant on the 3.2T ports at 400G, and also the LPO, which is the red one, which is also growing. So it seems that the LPO is really a mid-step between retime, which is blue, and CPO, which is green here. So I found this interesting.
This is really interesting, and it says the retime is like shrinking.
Yes, so maybe we should not take it for granted, but this is yes. This is how this market may look like. So, but 2030 is not that far, right? This is what is interesting.
It is.
So
yeah.
So it seems that what he said is there was a discussion panel after that. He said there are definitely challenges in CPO right now. In maintenance, also in yield and so on, and definitely it's not a mature technology, but with Broadcom and NVIDIA pushing this technology, they believe that this will accelerate, right? And there will always be some space for pluggables and so on, but in terms of ports, right? In terms of ports, and here I think this is everything scale up and scale out. So maybe some of them, they are already so optical scale up. In terms of port, they see the CPO dominating by 2030. And this is a picture of Interconnect from Yamamashi. And what I just wanted to show is that they have good performance up to 100 gigahertz. So in theory, this can support 448 PAM4 signaling. But he said that there is an industry is not ready to change this, and they want to stick to the existing pluggable concept and so on. And therefore, it seems right now that on the electrical side, for instance, for copper connection or for CPC connection from the chip to a module, for instance, it will be PAM6. Yeah, that's all from my side.
Thank you, Adrian, for sharing this observation. Anyone has questions or something they'd like to bring up and discuss?
Yeah, this is Ryan from TerraHop. I think thanks for bringing this perspective from this OCP event. I'm just saying many of these questions you raise are already well discussed within the community, PAM4, PAM6 debates, and already going on for a while. So it's continued to be flushed out, I guess, by different players and see how this settles on the electrical side, optical side. It's going to be a very again, debate and evolve about what the mix is between CPO and pluggables. I will say that's just one point of view. I mean, even at OC this year, you can continue to see different camps like Google is adamant about pluggability, and you see other more of a supplier side continue to push on the CPO. I would say it's going to be an interesting watch for the next few years.
Yeah. I'd like to share one observation that's very interesting, which is after Hadrian gave the talk, it was the most things that are surprising to me is Google and the partner decided to share their 1 megawatts of rack design in OCP event. So I'm wondering, does that mean they're gonna donate this back to OCP, and then the 1 megawatt is rack is gonna be pretty much is gonna be a standard in what they projected, which is like 2030, and that could be an interesting things of when we're working on as an optical group to thinking about all the connections, the size of the rack or the amount of a chip that squeeze into the the a rack size things, and the distance of travel would be totally different at that level.
That's an interesting comment, right? I think NVIDIA are probably going to push for that 1 megawatt too, right? They already have
Yeah,
megawatt.
I bet, because I think so, because they announced that something like a 600 kilowatts of things in their GTC, and then now the Google is like a one megawatt. So so
The
the
primary reason for that one rack is people want to continue to use copper. Now the question is, how many problems you're going to run into doing a 1 megawatt rack?
yeah, so that is very interesting things, is like how can optical even help when they decided to try to continue to use copper in that short distance, right? So that's our at least in I would say in our short term this years of the white papers that we'd like to publish is probably no need to worry about that. But in terms of the whole industry, we'll have to thinking about what's going on for next 5-6 years. All right. If no other questions, Hadrian, if you can, can you email me your files or
Sure. Yes, I'll
or
do this. Yes, I'll do this, Bobby. No problem.
Okay, great. And I'll put it into our Google Drive and share with everyone. And thank you again, Hadrian, to share your thoughts here today. And we'll see you next week. Bye, everyone.
Thanks.
Thank you. Bye-bye.